To implement two-space collection then, we'll just have this range that we're allocating into, the start and end of our space. And then we have a pointer within that, which is where we are currently allocating. So the main work of allocation, first we have enough, make sure we have enough space so far. If we don't, we collect garbage. But if by the time we get here, either because we collected garbage or we had enough space, then all we have to do is take that pointer, that's our allocation pointer. We bump up the space next pointer by the amount that we've allocated. We mark that it's not forwarded. This is kind of it's sort of marking it as white in advance, and then we return the allocated object. Collecting garbage is the more interesting step. So to collect garbage, instead of just having two spaces here, we're actually just going to always make up a new page, make up some new size, and then we'll free the old one using raw free after we copy everything out of the old one. And that copying process is copy from roots. So this is what's going to copy from the old space to the new space. And this new space pointer here, we pass an address to that to copy from roots so it can keep track of where it's going in the new space. And then once all of that is done, then we set the start and end space pointers to the ones we just allocated, and space next is whatever we have after we finished copying into the new space. Copy from roots then is just going to look at each root address, and it does a copy or forward. Notice there's no star in front of root addresses. So copy or forward needs to know not just the value in a root, but it needs to know the address of the root so it can update that address. We'll see that in copy and forward in a minute. And so after we've walked through all of the variables, all of the roots, to mark the things they refer to as gray, then we go into this loop where we're walking through the new two space to change things from gray to black. So that'll be the job of traverse copied. So copy or forward and traverse copied is our remaining bit of work. Copy or forward takes an address that's pointing to a node or pointing to null. If it's not pointing to null, then it's pointing to a node, so we can get that node that it's pointing to. We look inside that node, and the header now, instead of having a mark bit to say white or black, it now has have I been forwarded, which is serving the same role. We just renamed it to forwarded because if we have been forwarded, then we also use some room in the object to store the forwarding pointer. So if we're looking at an address that's referring to an allocated object, and that allocated object has been forwarded, then we just update the content of the address to be the place where it was already copied to. If not, then we need to copy it, and we're going to make it point to the new copy. Right? And copying is allocate some new space, a new object in the to space, copy over the data. This is the copying step that makes it a copy collector, because we have the old data in from space. We copy that into the new place in to space. That's always going to be a GC node size thing. Then in the from space, the old space, we mark it now as gray, as forwarded, and we set the forwarding pointer in case some other reference goes to the same object in the future. And then traverse copied, all it has to do is take this traverse pointer, which starts out at just after it starts out at the beginning of the to space. And as long as that pointer hasn't caught up to all the space that we've allocated in to space, then we can traverse the left and right values inside there. One thing you see here, neither traverse copied nor copy or forward is recursive at the C level. Right? We're no longer relying on the C stack or have that limit. That's because we're managing it ourselves in the to space. And the implementation of that is in to space. And you see the copying collector has just all the stuff that we talked about. Let's try it out. And what we see from the to space collector is that we use quite a bit more memory. We're using 6 meg instead of 2 meg, right? And that's because there's the overhead of essentially doubling the amount of memory that you want to use. But the benefit of to space is because allocation has been simplified.